Hey, at this point you should be familiar with the basics of pointers. In this example, I have a variable, an integer variable called var, and I initialize that to 55. And then in this next statement, I have a pointer ptr1, because I'll be adding more pointers later on in the video. This is a pointer to an integer, and of course a pointer stores an address, so we do the address of var to store the address of that variable var in the pointer. Now I'll do a couple of printouts, so I have a couple of console output statements. In this first one, we are concerned with the variable, the var. Okay, so in the next console output statement, I get the address of the var. The variable again has an address in memory, which we store again in the pointer. Okay, then I just do a tab, so I have some separation, and then I have the variable identifier by itself, so we should get 55 printed out here. Next, I want to print out the details of the pointer, so I have this console output statement pointer to a variable, and then I get the address of that pointer itself. Remember again that a pointer is a variable that stores addresses of other variables, so get the address of that pointer. And with this, we basically print out where the pointer is located in memory, as we do with the variable up here. Another tab here, and then I print out with the pointer name ptr1. What do you think this is going to print out again? If you think about it for a second, we assign the address of var to pointer1. Okay, so this right here should print out the same value that this should print out, the address of var. Then I do another tab, and then I dereference pointer1, which should print out the same that this is going to print out, which is 55. Build around that, and you can see that is what we get. For the variable, we get an address, some address. Of course, if you build and run a similar program, your address will be different. We get the value, which is 55. I just use values like 55 for readability to make it easy for you to read. Then we have the details of the pointer to the variable. We get the address of the actual pointer variable in memory. Okay, so that has its own address, and then we print out ptr1, so in other words, what the pointer stores, and that is going to be the same address that we get up here under the variable section. The pointer stores the address of that variable in memory. Then we dereference that pointer to get 55 again. Alright, so this is the example that we'll build on throughout this lecture. Now moving on, let's say we want to store the address of a pointer in another pointer for some reason. Okay, you are familiar with this sort of statement now. We are storing whatever this pointer1 stores, which will be the address of the variable var. And we are going to assign that address to pointer2 in its initialization. And then you can go into reference pointer2 and you should get the same sort of values. And actually, I'll just copy this here. And build around that. From this, we see both pointers, pointer1 and pointer2, both have their own address in memory, but they both store the same address, the address of the variable var. Okay, you can see both of these are the same. Okay, but let's say we want to do something else now. Let's say we want to store the address of pointer1 in pointer2. Okay, we want to store the actual address of pointer1, so not the address that the pointer1 is storing, but the address of pointer1 itself into some pointer, in this case pointer2. If I try and build now, we'll get an error. We'll get some weird error here, cannot convert from int asterisk asterisk to int asterisk. Okay. And the same if I hover over here, the IntelliSense will show us a value of type int asterisk asterisk cannot be used to initialize an entity of type int asterisk, which is not all that useful, but we can see we basically have two different types here, an int with 1 asterisk and an int with 2 asterisks. And this is where pointers to pointers come in. A couple of illustrations starting off with this example. A pointer to a variable. We have the integer variable to the right. At the top of the rectangle, we can see it has an address. Within the rectangle, we have var, that is the variable name, that is of type int, and it stores the integer 55. To the left of that, we have a pointer called ptr, that is a pointer to an integer. It has its own address right at the top of the rectangle. Again, a pointer is basically a variable that stores an address, so the pointer variable will have its own address in memory, and it stores an address, it stores the address of the var variable. Next, let's say we have a pointer to a variable, and in this way we can basically create a chain of pointers. To the left, I have introduced a pointer to a pointer now. We can see the type is a pointer to an integer. Okay, so we have 2 asterisks. That is also a variable and has its own address, but it also stores an address. In this case, it's going to store the address of a pointer. So as we can see with this illustration, a pointer to a pointer stores the address of a pointer. And so with this, we can have a pointer to a variable that stores a value that we can use, such as 55, for example. Okay, let's look at an example in Visual Studio. So I'll just copy this line here. Next, we are dealing with a pointer to a pointer, so I'll rename that string to pointer to pointer. Then again, we want to fetch the address of that pointer, ptr1, and actually I'll just rename that to pointer. and then I'll rename pointer2 to pointer to pointer just to make it easy to read here. Because we want to get the address of the pointer to the variable. We don't want to fetch the address or the value that it stores, we actually want to return the address of the pointer itself. And then we want to store that in a pointer to a pointer, so we have to add another asterisk here. Pointer to pointer is a pointer to an integer. Then in the next statement I do this console output statement again. The first output in this console output statement is going to be the address of the pointer to pointer variable itself. Then we do a tab. Then I use the identifier of the pointer to pointer, ptr to ptr. And as with the pointer to the variable, that is going to fetch the address that the pointer to the pointer stores. So that should actually print out the address that it gets printed in this statement, in this first section right here. Okay. Then we have another tab, and then we do this dereferencing right here. Now when we build a run, we actually will not get the value that we would expect by dereferencing pointer to pointer. So let's just build a run to see that. Okay, so we're familiar with the variable and the pointer to variable printouts by now. The pointer to the variable will print out its own address, followed by the address of whatever it stores, in this case the integer variable var. Then we dereference that pointer using the asterisk operator and the pointer name to get 55. But look at the pointer to the pointer now, it prints out its own address, followed by the whatever it stores, which in this case is going to be the address of this pointer, the pointer to the variable. Okay, we can see those two addresses match. They end with FA2C, okay, in this example, in this run. And then in the next printout, we actually dereference the pointer to the pointer, but we do not get 55 here, we actually get the address of the variable, which is stored in the pointer to the variable as well. So how do we get that 55 now? Well, we have to do another printout. First we print out the address of the pointer to pointer, then we print out whatever it stores, which is going to be the address of the pointer to the variable. Then we're going to reference that a single time, which is actually going to return the address that the pointer to the variable stores. It will print out that address. So over here we have to dereference twice, and that should now give us the value 55. Build around that. It prints out the address of the pointer to the pointer variable itself. It prints out the value that it stores, which is going to be the address of the pointer to the variable. See those two match. And then also it's going to print out whatever the address is that the pointer to the variable stores as well. And then we dereference that another time, and then we get 55 printed out because that is what the variable stores. That has this address right here as well. As we've seen in this demonstration, we can use the indirection operator cumulatively to dereference pointers to pointers. Okay, the first dereference is going to return the address stored in the pointer to the variable because that is the address that we currently store. So we dereference that address, and that is going to give us the 55 printout. And it's important to note that this chain can continue. Okay, in this statement we store the address of the pointer to pointer in a pointer to a pointer to a pointer to an integer. I'll copy this statement. First we'll print out the address of the pointer to the pointer to the pointer. Next we will print out whatever it stores, which is going to be the address of the pointer to the pointer. Then we'll go and dereference that once, which will basically return the address which is stored in whatever it is pointing at. So in other words, the address which is stored in the pointer to the pointer. Okay, so I'll do pointer to pointer with two asterisks here. I'll do another tab. Now I'll have to dereference the pointer to the pointer to the pointer 3 times to get the actual value. That is 55. Build around that again. And you can see what I mean. First we get the address of the pointer to the pointer to the pointer. Then we get what it stores, which is going to be the address of the pointer to the pointer. Next we get the address that the pointer to the pointer stores because we dereference the pointer to the pointer to the pointer. That is once. And what do we get when we dereference this address right here? Okay, we can see we have this address right here. What happens when we dereference the pointer to the pointer? We get this address right here. And that is the address that is stored by the pointer to the variable. Ultimately, we get this address which is stored in the pointer to the variable, and by dereferencing 3 times we get the 55 value. And so forth. Now this can seem a bit silly, but it is quite rare to come across this in C++. but I'm covering it here just in case you come across that. And then also, if you want to go and allocate a dynamic to the array, then you also need to use pointers to pointers. We'll talk about that later in the lesson. One final example with this, we've seen that we can access the variable indirectly using a pointer to a pointer by dereferencing that pointer to pointer twice. Now, of course, we can also write to that memory location. In this example, I assign 75 to this right here, so I dereference pointer to pointer twice, which is eventually going to give us the variable itself, so we can actually write to that. We have to think about what it means to dereference a pointer. If you remember, dereferencing a pointer gives us access to write to or read from the address that the pointer stores. Okay, so we can either fetch, or in other words, get to the value that is stored in that location, or we can write to that. That is in the case where the variable is not constant, we don't have a constant pointer. To make this simple, I'll actually change this to 2 here, and then I'll go back up to here. I will dereference the pointer by using the indirection operator. So what do we do in this statement? We dereference the pointer. It is going to return an L value. We are going to write to that location. To what location exactly? Well, to the location that is stored within the pointer, PTR. So we assign 1 to that. And actually, I'll move that down. Okay, we have the variable first. Then we have the pointer to the variable. Then we want to write again. We want to assign 2 to what? Well, we dereference this PTR to PTR. We are going to dereference twice. The first time we are going to get what? We are going to get the address that is stored in the pointer PTR. Then we are going to dereference that again to access the memory location stored in PTR. And what does that mean? Well, we want to access the variable itself. Okay, and so we can write to that. So we're no longer going to get 55, we are going to print at 1, 2, and to do that here with the pointer to the pointer to the pointer, we have to dereference 3 times. Pointer to pointer to pointer stores this address right here, the address of pointer to pointer. So by dereferencing this here, we can access that memory to read or write to it. But then we dereference once more. So that gives us access to the memory address stored in the pointer to the pointer, which of course is the memory address of the pointer. Then we dereference once more, which gives us access to the address which is stored in the pointer itself, which of course is the address of the integer variable var. So we can now write 3 here to that right to there. Okay, so in this way we indirectly store the variable 3 in the memory location of the variable var. Build and run this. And we can see that those values have changed. First, the variable is going to print out 55, and then we're going to get 1, 2, and 3. Now, I would like to note, if you change the type of the variable up here, for example, let's say to a float, then of course you'll get an error. If you try and build this, cannot convert from a pointer to a float to a pointer to an int. And similarly, if you try and change the pointer to a pointer, you will also get an error right here. A type pointer to int cannot be used to initialize the entity of type pointer to float. Okay, you will get a failed with that. So that is going to wrap up this quick look at pointers to pointers and how that relationship works. To wrap up this lecture, pointer to a pointer is a pointer variable that stores the address of another pointer of the same type. We will see a couple more examples of pointers to pointers throughout the rest of this lesson.